Hello, I'm Li Hao. Welcome to another day of Advent of Code 2020. So, Advent of Code is a series of programming challenges on the Advent calendar. On each day, you have one challenge, and within the challenge, you have two parts. Solving each of the parts gives you one gold star. So, the aim of this challenge is to solve all of the challenges and get 50 gold stars. So, today we're gonna do day 22. And if this is the first time you are watching this video, which means that you are losing out a lot, we have been doing this challenge from day 1 all the way to day 21. And if you want to watch them, please click the link over here. Go and click them and see you. So let's continue on day 22. So let's look at the Advent calendar. So day 22, the crab combat. Well, it only takes a few hours of sailing the ocean on a raft for boredom to sink in. Well, fortunately, you brought a small deck of space cards. You like to play a game of combat, and there's even an opponent available. Small crab that climbed aboard your raft before you left. Well, fortunately, it doesn't take long to teach the crab the rules. Before the game starts, splits the cards so each player has their own deck, which is your puzzle input. Then the card consists of a series of rounds. While both players draws the top cards, and the players with the higher value card wins the round. The winner keeps both cards, placing them on the bottom of their own deck so that the winner's card is always above the other cards. If this causes a player to have all of the cards, they win, and the game ends. For example, consider the following starting deck. Player 1 and Player 2. Okay, so the arrangement means that the Player 1's deck contains 5 cards, 9 on top and 1 on the bottom. And the player 2's deck also contains 5 cards with 5 on tops and 10 on the bottom. Okay, so the first round begins with both players drawing the top card of their decks, 9 and 5. So player 1 has the higher card, so both cards move to the bottom of the player 1's deck such that the 9 is above the 5. Okay, so in total it takes 29 rounds before a player has all of the cards. So round 1, 9, 5, and then you put both to the player 1's deck. And second round you get 2 and 8, and then players 2 win, so you put 8 and then 2 and the players 2 deck, and then now you see at 6 and 4, player 1 wins, so 6 move to the bottom of the deck, 4 also to the player 1's bottom pile, and then 3, 7, and then we continue many more rounds until the round 29, which player 1 left with 1 card, player 2 is left with 2 cards, and then you will win with 1 and 7, so player 2 wins. So once the game ends, you can calculate the winning player's score. Well, the bottom card of their deck is worth of the value of the card multiplied by 1. Second from the bottom is worth value multiplied by 2, and so on and so forth. So with 10 cards, the score will be multiplied by 10, so the winning player's score will be the 3 times 10, 2 times 9, 10 times 8, and so on and so forth, and 306. So once the game ends, the winning player score is 306. So play the small crab in a game of combat using 2 decks you just dealt. What is the winning player's score? So begin, we get our puzzle input. Okay, let's save it. And let's copy it to day 22. And let's start with code day 22. So, okay, so as always, we are going to read from the file content. .22.text, encoding as UTF-8. And then let's take a look at how the input file looks like. So it starts with player 1 and then a list of cards. I believe it's 25 lines. And then player 2, another list of cards, which again is 25, I think. Right. 1, 2, yeah, 25 number of cards. So what we're going to do is we're going to read the decks for player 1 and player 2 first. And player 1 and const player 2. I'm gonna have a line, let line equals 0, 1. So 1 will be, we just keep on the player 1, right? So lines equals to content split, new line. So while line equals to, not equals to a new empty line, then all of these are player 1 stack. So player 1 dot push number line plus. When we hit empty line, probably we're gonna add 1 and 2. Line plus equals 2. Skip 2 lines. And continue to do the same thing again. And this time around, we're gonna push to player 2. So just to check, player 1, player 2. With all the cards, right, for player 1 and 2. And let's continue to the puzzle. Right, so the puzzle itself says that the rule is to look at topmost card and choose who is the winner, and we'll shove it to the winners where the winning card on top and the losing card on the bottom. Right, so and we keep playing this while player 1 and player 2 still has any cards on the deck. So while player 1.length and player 2.length, we're gonna look at we're gonna find the winning player, right? So the winner will be, okay, so we're gonna call determine winner 1, 2, right? So if player 1 top deck is greater than player 2, then the winner will be, player 2, 0. And winner will be player 1, right? Player 1. Over here, I think I will return an array of two different players. So I can, so the first one is a winner and the second one is a loser, right? So here the winner is player 2, loser is player 1. So I'm gonna say winner and loser equals to determine winner, player 1, player 2. Then we're gonna take 2 cards and put it, so winner dot shift. So remove the first element and then we're gonna put it to the last pile, the winner. We're gonna push again loser dot shift. Right. Just keep doing this until they are run off cards. And when we reach the end of it, then we're gonna say we'll determine a winner again. Winner equals to determine winner. Player 1. Oh no, I think we don't need to. So player 1.length. Then if player 1 still have cards, then player 1 is the winner. Or else it would be player 2 is the winner. Right, so once we have the winner, then we're gonna add calculate the score. So let's score equals to 0 and let's we're gonna loop through from, so we start from the rightmost, then that means I will equals to the player the winner dot length minus 1. Also we will start from adding multiply. So the multiplier will start from 1, 2, 3, 4, 5, right? So the multiplier start from 1. And while I is greater equals to 0, then I minus minus, multiplier plus plus, score plus equals to winner I times multi. And last but not the least, we're gonna console out the log of the score, and then let's run this again. So we have a score and it looks legit, so we're gonna paste it in And that's the right answer. Okay, so we have solved the first part, and let's move on to part 2. So continuing on part 2. Well, you lost to the small crab. Unfortunately, crabs aren't very good at recursion. So defend your honor as a rough captain, you'll challenge the small crab to a game of recursive combat. Well, recursive combat still starts by splitting the cards into 2 decks. Well, you offer to play with the same starting deck as before. It's only fair. Then the game consists of a series of rounds with a few changes. Before either player deals a card, if there was a previous round in this game that has exactly the same card in the same order in the same player's deck, the game instantly ends in a win for player 1. Well, previous rounds from other games are not considered. Okay, so what are games? Let's take a look. Okay, so otherwise the round cards must be in a new configuration. The player begins the round by each drawing a top of the card of the deck as normal. If both players have at least as many cards remaining in the deck as the value of the card they just drew, the winner of the round is determined by playing a new game of recursive combat. But otherwise, at least one player must not have enough cards left in the deck to recurse. The winner of the round is the player with the higher value card. So as in a regular combat, the winner of the round, even if they won the round by winning a game, takes 2 cards dealt at the beginning of the round and places them on the bottom of the card. Again, so that the winner card is above the other cards. Note that the winner card may not be the lower value of the 2 cards if they won the round due to winning in a sub-game. If collecting the game cards by winning a round causes a player to have all the cards, they win and the game ends. So here is an example of a small game that would loop forever in a game of infinite game prevention rule. During a round of recursive combat, if the players have at least as many cards in their own decks as the number of cards they've just dealt, a winner of the round is determined by recursing into a sub-game of recursive combat. So if player 1 draws the 3 cards, and players draw the 7 cards, and this occurs if player 1 has at least 3 cards and player 2 has at least 7 cards. So not counting the 3 and 7. So after drawing those, if you're still left with 3 and 7 cards, each of the players, then you'll play a recursive combat. Well, each player will create a new deck by copying the next card of their deck. The quantity of the cards copied is equal to the number of games they drew to trigger the sub-game. Well, during the sub-game, the game that triggered is on whole and completely unaffected, so no cards are removed from the player's deck to form the sub-game. Okay, so they drew 3 cards. Okay, so player 1 will draw 3 cards, player 2 will draw 7 cards, and then they will go and play a sub-game. Right, so here's the gameplay. So starts with player 1, 9 and 5, right? Player 1 does not have 9 cards left after that, so we will do a regular combat, which is 9 greater than 5, right? Player 1 wins. 2 and 8, right? Player 2 does not have more than 8 cards left. So regular round, 2 and 8, player 2 wins. 6 and 4, player 1 does not have 6 cards left, so regular round, 6 and 4, player 1 win. 3 and 7, same thing again, regular round, player 2 wins. 1 and 10, regular game, player 2 wins. 9 and 8, again, we don't have enough cards, so regular round, player 1 wins. 5 and 2, regular round again, because you only left with 4 cards, so player 1 wins. 6 and 7, well, not enough card, regular round, player 2 wins. 4 and 3, we have 4 cards left and 3 cards left, so sub game, right? We are going to play a sub game. So we're going to copy all the remaining cards. No, we're going to copy 4 cards from player 1, 3 cards from player 2, because 4 and 3. I'm going to continue to play a game, right? 9 and 10, player round. So 9 and 10, so player 2 wins. 8 and 1, regular game, player 1 win. 5 and 7, regular game, player 2 wins. 2 and 10, well, regular game, player 2 wins. 8 and 9, player 2 wins again. 1 and 7, player 2 wins. So winner is player 2, right? So we go back to the previous game, game 1. So now player 1's win. Player 2 wins. So 4 and 3 are put on the player 2's deck. And because player 2 has 3, so 3 is placed on top of 4. So 9, 10, again, regular game. Let's see what anything special. Okay, so 2 and 6, now we go to a sub game. 8, 3, and 1, 4. And then we go again another sub game of the sub game, right? And then player 1 loses. So go back to game 3, so player 1 lose. And then continue to play a regular. And then player 1 lose again. So we go back to another main game and then we continue to play. Yeah, I think we get the idea, right? At the end when we win, we have this. And again, after the game, calculate the score. And using the same original rules. So now the score will be 291. So defend your honor as a rough captain by playing the small crab in a game of recursive combat. Using the same 2 decks before, and what is the winning player score? So let's dive in. Right, so when we do a determining a player, we are going to also determine whether the length we have remaining cards, and then we continue to play the sub game, right? So if player 1 dot so the first card is greater equals to the player. No, sorry, it's less than equals to player 1 dot length minus 1. So we remove 1 card, and if it's greater or you have exactly the same number of cards, then you can go for the sub game. But this also applies to player 2. Player 2. Right, then we play the sub game. Right, play sub game. Right, if not, then regular game, which means player 1 will be winner or player 2 will be winner in this case, right? Regular game. Okay, so here, this is our gameplay, right? We loop through and then we keep determining a player. So this one, since we're gonna recursively doing the game again, so we're gonna wrap this around as calling like the gameplay or play game. Player 1, player 2. I keep playing, and once we found the winner, right? So we're gonna return the winner or the loser. We're gonna say player 1 dot length. Then player 1 will be a winner, right? So we're gonna return the same way of determining winner. So we're gonna say player 1 and player 2, or player 2, player 1. Right, so we're gonna play the game. So here we're gonna return play game. So here we're gonna slice from 1 to player 1 the length plus 1. Player 2 dot slice 1 player 2 0 plus 1. Right, so we're gonna take up from the second cards onwards to the number of cards determining by the card on the first card, right? So we're gonna play the game and it will return us the results, the winner or loser. Right, so then we continue to play this game. Okay, and then we just keep playing. And then so here we're gonna change a bit. So we're gonna say winner will be play the game player 1 and player 2. Right? We can ignore the loser, we're not using a loser account. Yeah, we get a winner. Okay, and then hopefully that will be it. Except we also need to make sure that we don't run into a recursive loop in this while loop. So as it says that if, say, infinite game prevention rule, right? So if it's going to have if we are going to if either player deals a card, and if there was a previous round in this game that has exactly the same card in the same order in the same player's deck, then the game instantly ends. Right? Same order, same player. Right? So we're gonna serialize like the deck, and then we're gonna store it in a set. And then we're gonna find, and every time we do this, and then we determine whether we have seen this configuration before. Right? So it's more like us. So we're gonna have a set first, new set, and we're gonna deck configuration. Or how about serialize deck, serialize player 1, player 2. So if we have seen this before, then we're gonna immediately declare player 1 is the winner. So player 1, player 2. Player 2 is the loser. And then if not, we're gonna, if we're not seeing this, then we just add this to the serialized deck to the set, so that next time when you see it again, we will immediately declare player 1 is the winner. And how do you do the serialize? Player 1, player 2. Since they are all two arrays of numbers, we're going to join them with maybe with a comma, the most simplest one. And just to determine that this is player 1 and player 2, we're going to add something like a dash in between, because all of numbers are positive, there won't be a dash. Player 2 dot join. Yeah, so that can be good enough as an identifier to split the two arrays. And I'll just return this. And I think that's about it. So let's try run this again. 9357. That's fast. We have a number, and let's paste it in and see whether it's the correct answer. Too bad it's not the right answer. Well, let's get back. Let's take a look at. Let's try run this with an example. Inputs from. See, what's the example? Starts with 92631. Yeah, should be this one. Let's try this as an example and see what goes wrong. Right, and so we're gonna loop through. We're gonna see what is the winner looks like. Winner, infinite loop, is it? Okay, so let's take a look. So we're gonna play a game. We're gonna log this out. Play game. Player 1, player 2. I think it's just the file input. So you play a game 92631, and then play a game again at 9. It doesn't look good because we ended up in a shorter array. What's going on? Okay. So let's see. So we play with this. Okay, so what I'm gonna do is I'm gonna keep looping. I'm gonna say this log. So play game 9. Okay, so let's compare it with the example. Okay, let's open this on the site. right? So we start with 9, 2, 6, 3, 1, 5, 8, 4, 7, 10. Okay, round 2, 3 looks good. 7, 3 and 7, 1 and 10, 9 and 8, 5 and 2, 6 and 7, 4 and 3. So 9, 8, 5, 2, 10, 1, 7. And then 8, 5, 2, 1, 10, 1, 7, 10, 9. 5, 2, 8, 1. 2, 8, 1. 8, 1 and 9, 7, 5, 10, 2. 1 and 7, 5, 10, 2, 8. And then probably we'll go back to the previous game where hold on a second. Okay, so we determine the winner and the loser in this round. We didn't shift. We didn't take out the first and second. Okay, so probably when we win, we didn't really player game. I'm gonna print out a winner. Run this again. So at the end of it, this should be the winner. Oh, okay. Oh, okay. I think I know what happened. Oh, I think I know what happened because we are returning an empty array immediately. Because okay, so this is not the exact Okay, so we returned array of player 1 and 2, but that is like a new array, but we don't want to we want to return the original array. That is a new array that we created over here. Right? So we're gonna copy this. Let's say sub player 1 equals to this. Const sub player do this. So sub player 1 and sub player 2. Okay, so we have winner and loser. I think we need the winner just good enough. So if winner is the sub player 1, then we're gonna return the original player 1, player 2, else gonna return original player 2 and player 1. Equals. Let's try run this again. 291. It's the answer, right? So I think we got it. I think let's revert this back to the original inputs. Let's clear up a bit of the console. Let's just remove unnecessary ones. We don't need this. We don't need this. Okay, I think we got it. And let's try run again. Okay, so we have an answer, 33441. So let's paste this in and let's see whether that's the right answer. And we solved day 22. So that's about it for today. If you like this video, give me a thumbs up. If you feel that I have something that I can improve on, please comment down below. Love the comments. And this is day 22 and day 23 will coming up right next. So please be sure to subscribe to my channel. It will be here on the right, on the left on your screen. That's all for today. So see ya next time. Bye bye.